The prototype system you're reviewing is an evolution in commercial refueling. The operating principle is based on a patented closed-loop delivery method utilizing both pressure and vacuum. In designing the system, the primary objective was to dramatically minimize the bottleneck and logistics problem associated with peak refueling intervals and increase the efficiency of the time spent in the day-to-day refueling within large commercial fleets. The pressure and vacuum, in conjunction with a unique manifold system, allows multiple fuel tanks to be rapidly filled from a single capless connection point, without foaming or tank pressurization. The dispensing system also makes it possible to introduce additional maintenance fluids to various reservoirs from the same single connection point. By combining these mechanical components with an RF-enabled ECM module, maintenance efficiencies are further enhanced through data acquisition, opening the door to subscriber-based services. This proof of concept dispensing gun connects, dispenses, and disconnects without fluid or vapor release. It eliminates accidental overfills and will enhance SPCC compliance for captive fleets, and eventually will be available through over-the-road travel plazas. The challenge in designing this dispensing gun was to make the multiple valves connect and disconnect with a minimum of movement. The couplers were separated into two groups to reduce spring resistance during gun connection. The fuel supply and vacuum returns connected first. Then the three additional connectors on a separate slide rail engage shortly thereafter. To accomplish this, we've engaged a special fulcrum lever. The push motion of this lever engages the two couplers with a cam action. When the gun is in position, a spring tension pawl mechanically grabs the inner edge of the receiving box and acts as a pivot point. This takes advantage of the push-to-connect feature of the hydraulic valve assemblies. Each collar on the female coupler are allowed to float independently to complete a solid valve connection. The same fulcrum lever, when manually retracted, disengages the two sets of fittings by engaging a pull rod connected to the ball lock retaining collars. The rod is centrally located in the body of the gun, and this rod is also designed to disengage the valve collars by a solenoid that's actually concealed in the body of the gun with a pull action. The solenoid can be activated by two methods. A manual push button stop located on the top of the gun above the handle assembly, and also if fluid is actually detected inside the return path, a flow switch is tripped, which automatically disconnects the couplers through that same rod. Since the gun is actually secured to the vehicle during fueling, it was necessary to add a magnetic interlock to prevent the vehicle from moving. This probe actually comes in contact with a proximity switch located inside the receiving unit. The switch interrupts an electrical circuit, such as a neutral switch or a pneumatic brake, and prevents the premature drive off of the vehicle.